the whole industrialized human race is going to suddenly be lost.
Introduction: the cosmic drama of a supernova. This supernova is more than just a stunning visual event. It is a cosmic message, a reminder of the universe's boundless power and our place within it. Throughout history, people have looked up at the night sky and witnessed many celestial events, but nothing compares to the power of a supernova. At the end of its life, a massive star can release more energy in a few seconds through a spectacular explosion than our Sun would emit in its entire 10 billion-year lifetime. The spectacular event, a supernova unveiled. The impending supernova is expected to turn night into day and captivate billions of people, making it the most breathtaking event of the century. Several theories surround its countdown. What impact will it have on Earth? If we were to stare directly at the explosion, what would we see? And most intriguingly, what mysteries of the universe will it reveal? Exploring the phenomenon, understanding supernova. Join us as we delve into this once-in-a-lifetime supernova, set to illuminate the night sky worldwide. From birth to death, life cycles of stars. From the moment of our birth to the moment of our death, we pass through many stages. Similarly, stars, including enormous ones shining in the night sky, undergo life cycles. A supernova is a tremendous interstellar explosion occurring when the universe's largest stars reach the end of their lives, whereas smaller stars simply fizzle out. The stellar drama: how supernovas shape the universe. The death of an astronomical heavyweight is a showstopper. These stars spend their lives cannibalizing their own inner materials and sometimes the remains of neighboring stars for fuel. When they exhaust their resources, they collapse inward and then explode outward in a dazzling display that outshines even entire galaxies. Frequency and observation. Supernova in our galaxy. In a galaxy as vast as our Milky Way, a supernova explosion is estimated to occur approximately every 50 years. The most recent observable supernova in the Milky Way was thought to have happened in the late 1600s. However, in 2006, astronomers discovered the afterglow of a supernova that had gone unnoticed due to cosmic dust. Detecting supernova: challenges and discoveries. While cosmic dust obscures the majority of the estimated 1 billion supernovae that explode annually outside our galaxy, some are detectable even with binoculars due to their extreme brightness. For instance, a supernova that burst 21 million years ago was visible to Northern Hemisphere observers in September 2011. Amateur astronomers and discoveries. It doesn't take a professional astronomer to make significant discoveries. In January 2011, a 10-year-old girl discovered a supernova in a galaxy 240 million light-years away. Scientists often rely on amateur astronomers to spot new celestial phenomena, especially as stars on the verge of supernova transition from red to blue. Historical observations. Ancient accounts of supernova. Astronomers in ancient China made the first recorded observation of a supernova some 2,000 years ago. This mysterious new star puzzled them before vanishing without a trace after 8 months. However, in 2006, astronomers noted similarities between these ancient records and known supernova remnants. Conclusion: supernova windows into the universe. Supernova continue to intrigue and inspire astronomers, revealing insights into the vast and dynamic universe we inhabit. As we gaze at the night sky, these cosmic explosions remind us of our place in the cosmos and the ever-evolving nature of celestial phenomena. The bright remnant, aftermath of a supernova. Telescopes weren't necessary to witness this spectacular event. The Large Magellanic Cloud, a neighbor galaxy to the Milky Way, was the stage for this supernova. In 2011, scientists observed its debris burning brightly, marking a historic moment as it entered a new decline stage. The stellar life cycle, from birth to supernova. Where did this star's self-destruction begin? It started from humble beginnings as a baby star formed when gas and dust collapsed under gravity's strong force. As the young star's core drew in more material from the interstellar medium, a maturation process lasting up to 50 million years ensued. This phase was followed by an adult stage lasting another 10 billion years, powered by nuclear fusion of hydrogen into helium in the star's core. The end game: supernova explosion. The end of a star's life begins when its hydrogen fuel depletes, causing its core to collapse. As the core collapses, the star's outer layers undergo hydrogen fusion, transforming into a red giant. Eventually, if the star is massive enough, it will explode into a supernova, synthesizing heavier elements before its core collapses. Betelgeuse, a looming supernova. Betelgeuse, one of the closest potential supernova to Earth. lies approximately 1,000 light-years away. Its eventual explosion is a certainty, though its timing remains uncertain. Observing such a galactic explosion, particularly one as nearby as Betelgeuse, would be an extraordinary event in our lifetimes. Internal mechanisms, understanding Betelgeuse's fate. Betelgeuse is believed to be in its final stages of core carbon burning, a process that lasts about 1,000 years for massive stars like it. As it nears the end of this phase, Betelgeuse could potentially burst into a supernova, though the exact timing is challenging to predict. The Great Dimming, Betelgeuse's mystery. The sudden dimming of Betelgeuse in late 2019, known as the Great Dimming, sparked global excitement and speculation about an imminent supernova. Despite fluctuations in brightness, Betelgeuse has not yet exploded, leaving astronomers intrigued by its unpredictable behavior. Betelgeuse's unprecedented activity. According to astronomers analyzing data from various observatories, including NASA's Hubble Space Telescope, the red supergiant star Betelgeuse experienced a significant event in 2019. A massive surface mass ejection occurred, obscuring a large portion of its surface. Unlike typical stars, Betelgeuse's coronal mass ejection released 400 billion times more mass than a regular event, causing the notable dimming observed. Supernova safety and spectacle. Even if Betelgeuse were to explode, it is too far from Earth to cause any harm. Supernova only pose a threat within 160 light-years, while Betelgeuse is approximately 640 light-years away. Its eventual explosion will be a breathtaking sight visible to everyone on Earth, providing astronomers with a unique opportunity to study such an event. Corona Borealis, the stellar cycle. Meanwhile, another celestial spectacle awaits Earth's skies, the recurrent nova in Corona Borealis. First observed in 1977 by an abbot in modern-day Germany. This phenomenon appears every 80 years. It originates from a white dwarf accreting matter from a nearby red giant, culminating in a thermonuclear explosion visible to the naked eye as a new star, hence the name nova. Understanding nova, TCB's peculiar behavior. TCB Corona Borealis exhibits erratic brightness variations, unlike typical nova, which makes it a fascinating subject for astronomers. When TCB erupts, telescopes worldwide turn their attention to study its behavior, offering insights into these transient cosmic events. Nova vs. Supernova. Cosmic explosions explained. Nova, triggered by white dwarfs' interactions with companion stars, are powerful but not as catastrophic as supernova, which mark the end of a star's life. Despite their differences, both nova and supernova enrich their surroundings with newly synthesized elements. The role of nova in cosmic chemistry. One primary source of lithium in the universe may be nova, which also produce essential elements for life like oxygen, nitrogen, and carbon. Understanding nova is crucial for bridging the gap between astronomy and biology. Recurrent nova, erupting at least once every 100 years, serve as invaluable study subjects. Despite their predictability, only about 10 such systems have been identified in the Milky Way, with records dating back to 1917, 1787, 1866, and 1946 for TCB Corona Borealis. Ancient observations hint at its erratic nature, yet recent analysis predicts its next eruption in approximately 3 months. Observing TCB's eruptions. Leading observatories worldwide are poised to capture TCB's upcoming eruption across various light wavelengths, including optical, radio, and X-ray. This comprehensive monitoring aims to transform TCB from a cosmic anomaly into a source of answers for universal mysteries. Insights from neutrino detection. Neutrinos, elusive particles produced during cosmic cataclysms, can reveal hidden insights into the energetic processes behind nova. Detecting these neutrinos could provide a fresh perspective on the explosive physics of nova, although their detection remains a significant challenge. Evolution from nova to supernova. While astronomers study the explosions of nova, the evolutionary path to supernova remains a compelling question. Type Ia supernova, involving a white dwarf accumulating mass from a companion star until it explodes, are crucial cosmic yardsticks for measuring vast distances between galaxies. Understanding how white dwarfs accumulate enough mass to exceed the Chandrasekhar limit, leading to a supernova explosion, is pivotal for accurate cosmological measurements. Unraveling nova characteristics. During a nova eruption, the balance of matter between what remains on the white dwarf and what is ejected into space is critical. TCB's impending eruption offers astronomers an opportunity to study these dynamics, shedding light on the proportions of elements ejected into the cosmos. TCB's peculiarities. TCB stands out among nova due to its unusual characteristics. It maintains modest brightness for approximately a decade before and after an eruption, emitting a distinctive hot blue light during this period. Moreover, its pre-eruption brightness dip, occurring about a year before the eruption, serves as a unique and enigmatic herald of its explosive events. Understanding TCB's peculiarities. According to some theories, the matter secreted by the white dwarf could acquire a dusty covering near its eruption phase. This dust might form shells, obscuring the star's light and causing the pre-eruption dimming observed in TCB. Additionally, TCB exhibits a secondary eruption a few months after the initial outburst, though it doesn't match the brightness of the first. This phenomenon has puzzled astronomers, with theories suggesting it might not be a separate eruption, but rather a trick of observation due to the orientation of the system. The impact of a starless universe. Imagine a universe without visible stars. Planets orbit the Sun, but stars beyond the solar system are invisible due to a surrounding dark nebula. In such a scenario, crucial aspects of human history and development would be profoundly affected. Navigational challenges. Ancient civilizations relied heavily on stars for navigation, agriculture, and scientific advancements. Without visible stars, calendars, navigation, and understanding of physics would have been severely limited. Technological and cultural shifts. The ability to predict astronomical events and navigate the seas would be severely compromised, impacting global power dynamics, trade routes, and human migration patterns. Cultural and historical impacts. Historical landmarks like the pyramids in Egypt might not have been built as divine mandates derived from celestial observations would be absent. Major human migrations across oceans would likely have been impractical without celestial navigation. Island isolation. Islands like Hawaii, New Zealand, and Iceland might have remained uninhabited due to the difficulties in navigating across vast ocean expanses without the guidance of stars. In conclusion, stars have played an indispensable role in shaping human history and culture. Their absence in a hypothetical starless universe would fundamentally alter our understanding of the cosmos and hinder human progress across various fields,